Good day, students. You are welcome to Basic Technology class. Today, we're going to talk about orthographic drawing. As you can see on the board, we have a question on the board regarding a certain isometric block. The front elevation of the object above is indicated with arrow A. In first angle projection, draw to full scale the following views. A. The front elevation. B. The plan. C. The end elevation. So when you look at the object, you see that the arrow is indicated. We have arrow X and arrow Y. The front elevation of the object is indicated with arrow X. Arrow X is the front elevation. So we want to draw to full scale the front elevation, the plan, and the end elevation, which is also referred to as the side elevation. So when you view the object from the direction of arrow X, what do you see? And when you view it from the direction of arrow Y, what do you see? Remember that in the class, we talk about the principal views of objects. The first front elevation is always given to you. The arrow is always given as A or any letter in the alphabet. Then once the front elevation is given to you, the other side must be the side elevation or the end elevation. While the plan view is always viewed from the top. That is the plan. The plan view is always viewed from the top. So let's go ahead to solve the question on the board. From the direction of arrow X, the front elevation, when you view it, remember that we also talk about the principal planes of projection. Under the principal planes of projection of an isometric object, we talk about the vertical plane and the horizontal plane. We said that the front elevation and the side elevation are always viewed from the vertical plane, while the plan view is always viewed from the horizontal plane. So when you look at the object on the board, you see that the front elevation of the object, that is the side of arrow X, that is this vertical plane, that is the direction we are looking at. Then when you look at the direction of arrow Y, the vertical plane, this direction, that is where what we're going to consider. Then from this, you consider using X as our front elevation, and considering the plan view, you view it from the top, always from the top. That is the direction. Here, and here will be seen directly when viewed from the top. So let's go ahead. Now, dimension also is very, very important because the object has been dimensioned for you. So as you draw the views of the object, after drawing it, you have to also show the dimension as indicated in the drawing. So let's go ahead and draw the object. From the direction of from the front elevation, when you view it from here, this point to this point will be seen clearly from a person that is viewing it from our X. From here to here will be visible. This shape will be visible. So let me draw this line here. From here to this point, I remember it has to be in full scale as indicated in the drawing. Let's take this one to be our 127 millimeter. Okay, we want to take this side from this point to this point as well, which is 50 millimeter. We measure it out 50 millimeter. Okay, I come to the other side. From this point to this point, I'll be giving to you as 16 millimeter. That is equal to from here to here. I dimension that out as well. That is 16 millimeter. What is from this point to this point? See, this dimension I'll be giving to us, and this other side will be giving to us. We have to subtract 86 from this line dimension here to give us from this point to this point. 127 minus 86 will give us, I think, 41. That is 41. You measure that is from this point to this point will now be 41. Okay, measure it 41. Then from this point to this point now will be 50 minus this 16. That will be 34. Okay? We just draw it like that. Then we join this point to this point. Okay? Now, that is the shape we can see from the direction of arrow X. Now, if you look at this object very well, you see that a particular portion of the object has been cut out. For example, this part, there is nothing in this place. So it has to be shown in the drawing that there is a hidden detail. But of course, when you view it from this direction, this part of the object will not be seen. So because it will not be seen, we have to show in the drawing that there is a hidden detail in this drawing which cannot be seen by a person looking at this object from the direction of arrow X. So what is the dimension of this particular place? Okay, it was not indicated. I think it has to be indicated in the textbook. Okay, from this direction, from this point to this point is actually 19. Okay, 19. Okay, we have to show it. That is, from this point to this point now, we have to measure it and make sure that it is also 19 and show and bring out the hidden detail that is shown in the drawing with short dashes. Then the next one quickly is our plan view. We have to be fast because there is no time. When we view it from the top, we're going to see this place. And this place that was hidden when viewed from the direction of arrow X, we'll see here, here, here. This place is vertical plane and this place. And remember, they have the same dimension, 127, but this time by 67. So I project this point out because that line is 127. Okay. This is from here to here is 67. I bring up my 67. Then bring this one down. 127. Make it visible. And this one. Now I want to bring up from this point, from here to this place, this line, you'll see it's very visible. From the observer looking at the object from the top. That is 86, and that is this line projected out, and that line is visible. Okay, now I want to bring out this line from this point to this point. Okay, I measure it out. I take this place to be my 19. Okay, this one from this point to this point, which is 29, I bring it out as well. Okay, of course, that is the view. This is this point. This point here is here, here is here, while this point is here, and this other side is this place. We want to draw our side elevation, which is also referred to as the end elevation. Okay, let's project it out first of all. Okay, you can measure it out. That is this view now. When we view it from this point, from this direction of our Y, we are going to see here, this place is horizontal plane. It will only be seen when viewed from the top, and this place. And the total height is this plus 16 plus this one, that is 50. Okay, you can measure it out here and mark it off, or you project it because they have the same dimension with this one. Okay, project it out and project this one out as well. Project this out. Every detail is important. Project this out. Project this out. Project this out also, and project this. And finally, we come to this place and do the projection here. Okay, let's come back to the side elevation. From this this point 16 plus this point, that is this one, this direction here, that is this line. From this point to this point, that is this point. Then here plus this point, that is this. Okay, this line, this outline is actually visible. I bring it out. Okay, that is this point. I now come here, this line from here to here, that is from here to here. From this point to this point, that is here. From this point to this point, that is here. From this point to this point, okay, and here to here, we have that, and finally this point. That is just all about the end elevation of the object. The next one is to dimension the object on the board. To dimension it from this point, okay, here is 4186, which equals to 127. Then we have here 19, 29, 19. That is it. Then finally, we dimension here. Okay. This one is 16. 19 and what? That is 20. That is 35. Then 15 to make it 50. So it means that from this point to this point, you know, the whole dimension is from this point to this point, which is 50. From here to here, this point is 19. From here to here is 16, and from here to here is definitely going to be 35 subtracted from 50. I hope you enjoyed the lesson. I wish you all the best. Thank you and God bless.